So good morning, everyone, and nice to have you here today as well. Today we will start our day with presentations of laboratories that are participating to see what kind of research everybody is doing, so that we can hopefully foster some later collaboration. So we will have short presentations of each lab, and we will have some free time then to mingle and discuss what we have in common. And we will start with our guest, Ivo Popivanov from the New Bulgarian University as our first presenter. And here you go.
Thank you.
No more formalities from my side.
Thank you very much. It is really a big honor for me to be here and present our, let's say, fresh lab that we have at the New Bulgarian University. My name is Ivo, and I am affiliated with the New Bulgarian University and also with the University Hospital Alexandrovska, where I work also as a clinical neuropsychologist. So there I don't do work with EEG, but at the New Bulgarian University we recently renovated a lab that we had, and I'll show you a little bit about this lab. So maybe I can use one.
You can use the pointer as well.
Yeah, but
Is it on?
That should be on.
I'm not
Otherwise,
sure.
the arrows should work.
Ah, yeah, there it is now. I think it's easier with the PC. So a little bit of history of this lab. So it was actually first established at the New Bulgarian University around the year 2000. And this person, Professor David Popivanov, actually he's my father, he founded this lab as a point where actually the New Bulgarian University was a new university, just 10 years old at this point, and it was a place like a hub for cognitive science, people that are interested in cognitive science. So my father at that time worked in Bulgarian Academy of Sciences, and he decided to move to this kind of freshly built space. And at that time, it was difficult to get a commercial EEG for little money, so that it was house-built EEG device that was just 17 channels with 250 Hz resolution. So it was something like a basic step in recording at this time. But at some point, this device got broken, and then we didn't have opportunity to work anymore. So at 2007, we had an opportunity with the EU-funded project to actually buy a good commercial system that was from the company GTech. Probably most of you know this company from Austria. And then we got this 32-channel EEG that was used extensively in some project related to cognitive processes during translation from one language to another. So it was more on psycholinguistic side. But this device also got broken at some point, so probably we didn't have very good luck at this lab. And it was time that I was also doing my PhD abroad, so I was not in Bulgaria. So the moment I came back, it was in 2017, and colleagues of mine and we started working to revive this laboratory. So in 2021, we had an opportunity to actually, I won a grant for discount of the price of some product of this company, Science Beam. It's a startup company from Iran. And we got actually this new device that is 64 channel with 1000 Hertz resolution. So now at the moment we are using that new system. And here I have a couple of pictures of, let's say, the first time I opened the box that it got there. So I tried the cap, how it looks, and so on. We have actually 2 caps of 64 channels and 32 channels. And the EEG device is actually just that small, like a small amplifier box that is connected through USB to one of the computers that we have. Basically, what we had to start from scratch building this lab, so we had to buy computer screens, everything. We just had a room that we could use. That was actually Gergana can also tell you. It looks a bit like a storage. It was full of things that people don't use at the university. They just put it there, so we had to clean everything. And then basically we got one good computer for EEG data acquisition and analysis, another PC that we use for stimuli presentation, and a couple of screens, one of which is a high quality with quick refresh rate screen for the presentation of stimuli to the subject when we use visual stimuli. And we use several software. So we use eLife. This is the software of the company for data acquisition. We program our experiments with ePrime or CyclePy at the moment. I had some idea to use Cycle Toolbox of MATLAB, but we haven't used that so much at the moment. And so far we use MATLAB for data analysis. But we are actually eager to learn about MEE and actually doing the incorporated version of EEG Lab for MATLAB. So this is what we expect to hear in this workshop in Belgrade. So just a couple of things. As you can see, this is just 2 years since we are working in this lab, so we don't have much to show in terms of projects, but these are actually some ideas how the space of the lab looked like last year. Now it is a bit refreshed, but I didn't take a new picture, unfortunately. But actually we have a couple of more screens here. We still keep the Faraday cage, as you can see there. And normally we don't stay so many people. This was just a demo for students that we were groups of 5-6 people that were watching actually data acquisition at this point. So it was in an open day for the university we had last year. Here it is a couple of pictures of setup preparation that we had in those days. And this is another lab demo that we used to do it in a classroom. So what I like about this system, that is portable, it is just in a suitcase, and even on the laptop you can record data. So my idea was also to move to go to the clinic and record. I haven't recorded the patient yet, but this is the idea that what we can do in the future. So last thing that I really didn't think that much about that when I was preparing these slides, but now when I'm presenting it, I just figured out that I'm missing one slide to inform you about the current things and projects that we're working on at the moment. So there are a couple of things which are related to visual perception and perception of faces, and also of emotionally relevant stimuli. And these are two projects that you hear about in the next session. We are here with Gergana to present you these preliminary data. There are a couple of other projects which a colleague of mine from the faculty is working on. It's on the on psycholinguistic side. So she's working on actually electrophysiological correlates of understanding of words that imply direction, like up and down, and also sometimes non-concrete words that could be, or some kind of metaphors that also imply this kind of directionality up and down, which could be a sky which is always up, or something that is like grass that is down, and how this this can be seen in some of the electrophysiological signals. We have some projects which are in a very preliminary stage with working memory tasks. Since I'm working at the hospital with patients with dementia, my goal is to establish some electrophysiological tasks which could be used as a diagnostic tool for people with mild cognitive impairment. So this is something that we are trying to set up, but we are just in the beginning, basically the beginning position. We don't have any data for that so far. And the last slide I have, I think, is I hope I spelled it correctly in Serbian. So this is I just wanted to show you a list of people that are currently working in the lab as volunteers. This is Gergana, Vladimir Metodi, Bogumila, and Rosen, and they are the faculty member that I told you about. She's an assistant professor, it's called Ermina Jayan, who I didn't list here because these are just the people who work with me, but there are a couple of other people as well. So we are slowly gathering a team, mainly with volunteers and some let's say faculty members, and we are looking also for ideas and collaboration as well. So this is for me up to this point. I hope that I'm finding time. And if you have some questions or something else.
Yeah. You mentioned that you are working at clinic as a clinical psychologist.
Yeah.
And I'm wondering, is there any space for you there to do the things that you are doing in your lab? In a sense that is it your position as a clinical psychologist in any way intertwined with your lab work, or you just go there and work the things that are, said by the doctors or things, and nobody really cares about these aspects?
Yeah, this is a very good question, and I think you got the idea of my position, my double position, very well. In fact, at the moment, it's exactly as you say. It's like two separate worlds. I go there, I work with patients, mainly it's a diagnostic work. It's a lot of workload, and there is not much space for doing research in this way with EEG, but hopefully this is something that I think we will be able to change, because I'm a member of a team at the hospital which is kind of research oriented as well. Their main interests are the early onset dementias, and the research that is done there, it's mainly on biomarkers in terms of blood, cerebrospinal fluid biomarkers, and also neuropsychological markers for early onset dementia. So my dream is that actually we incorporate in this thing also some electrophysiological biomarkers. So, but this is something in the future that probably will happen. So my answer is more of a dream to shift from this position, but like a separate position, to something more integrated, hopefully. Thank you. Okay, thank you very much.
We will have more time to share during the break with coffee. And our next speaker is Milica Jankovic from the University of Belgrade School of Electrical Engineering.
The meeting. Yes.
non diciamo solo con i suoi propositi. Diciamo będę pouczył się. Что то инфекцию с этой формой директно. Назначил получить фото. Пока опция, зачем вот цикл. Дальше. Сегодня читаем, он тоже знает, что делать. Tu jest присутний. Вылечено, может, так вот не сообщить. Pointer, czyli вот. Stiamo dalle rati, sai? Stiamo dalle rati. Okay, Milica, go ahead.
Thank you. I'm Milica Jankovic and I work as an associate professor at the University of Belgrade School of Electrical Engineering. And first I have to say that biomedical engineering at our faculty has a very long tradition, so my duty is to also present you some historical perspectives. How to switch to arrows?
Arrows, yeah.
What do you to switch to another slide?
Just with arrow, but it was,
okay, okay. Okay. And unfortunately, I can't turn on this video, but on the left side you can see Belgrade hand that was created in 1960s, and this was the first adaptive multifunctional myoelectrically controlled prosthesis with the sensory feedback. And on the right side you can see the prosthesis that was constructed in 1980s. This was the Belgrade below knee prosthetic. And this was developed regarding the zero moment rules defined by academician Milomir Vukobratovic, and also our professor, academician Dejan Popovic, was involved in the construction of this neural prosthesis. And later, 15 years ago, academician Dejan Popovic and Professor Mirjana Popovic founded the Laboratory for Biomedical Instrumentation and Technologies, and the main focus of this laboratory was in the field of neurorehabilitation, primarily oriented to the patients after stroke, and in strong collaboration with the Clinic of Rehabilitation Dr. Miroslav Zlatovic in Belgrade. And they used the principles of selective functional electrical stimulation to prove effects of assistive technologies that were used in such kind of patients, not only in patients after stroke, but also in some other neurological patients. And the team members used gait analysis and wearable instrumentation to improve and to prove effects of these rehabilitation procedures. Today, our team members that belong to the research group for multimodal biomedical engineering are presented on the left of this slide, and on the right side is maybe more important for you in this moment, because it shows the local ecosystems and main partners that we have at this moment. On this list, we have some academic partners, but we are very proud about the list of clinical partners, as well as several industrial partners.
I will start with presenting the selected research activities that we have in our laboratory and in cooperation with different clinical partners. And I will start with preclinical studies that we do in cooperation with the Institute of Medical Physiology, Furia. Actually, there we work with medical experts on the experiments on rats. And the two scenarios we performed. One scenario was in epilepsy model, and the other scenario was in myocardial infarction scenario. And the results, the main point of this was to find the relation between heart and brain signals. And the results that we have published show are on the model of myocardial infarction, and these results show that there is the increased power in alpha, beta, and theta bands, and also there is increased peak frequency in beta bands a few hours after the drug administration. Next research activity is in the field of rehabilitation, but in this scenario we used the wearable instrumentation that was consisted of shoe insoles with force sensors, and also we used the inertial measurement units that integrates accelerometers and gyroscopes. And in the patient after stroke, we performed this wearable instrumentation to analyze their walking. And the original set of acquired signals we reduced using principal component analysis to the two principal components that we can visually present as gait cyclograms. And then we use these gait cyclograms to prove that functional electrical therapy has its effect in rehabilitation, and we compared gait cyclograms for paretic and non-paretic legs during the walking before and after functional electrical therapy. And we found that there are statistically significant differences in temporal synergies before and after the functional electrical therapy. And also there are some other results, but this is the main point because it is the main advantage of this finding temporal synergies in this kind of way in comparison to the conventional approaches that are based on some symmetry indices. Next research that I would like to present to you is in collaboration with the industrial partner, and it is in the field of non-contact sensing of vital signs. Primarily, we were oriented to the extraction of heart rate from Doppler radar signals using filter bank approaches and also using neural networks. And I have to say that these two papers are, at this moment, are my most cited papers. So this can just show you that this is emerging field for research activities. So how contact lasts to estimate the heart rate and then use that heart rate or respiration rate in some applications. Next research activity is in the field of multimodal data acquisition and data processing, and also this huge version of this slide will be presented on Thursday during the workshop that will be organized within this Cutting Gardens conference. What we tried to do, we tried to acquire simultaneously electroencephalography, electrocardiography or heart rate signal, we can say, eye tracking data, and electrodermal activity. All of these signals were synchronized, and we extracted multimodal features from all of this data and compared this. First, statistically compare these features between groups of students in the second and the third grade. Then we analyzed these features regarding the gender perspectives, and also we try to find the color impact that the background and overlays have on this approach, on this screen. And we found that it is very important to use the color for background or overlay if we want to screen dyslexia, early screen dyslexia. And after these statistical approaches, we focused on applying machine learning approaches only on eye tracking data. And we used traditional machine learning approaches and also deep learning approaches, and get the high accuracy in classifying children with dyslexia and children without dyslexia. And on the right side of the screen, you can see visual representation of eye tracking movements in the control subject and dyslexic subject. Next example is in the field that is currently interesting for us, and we work on this research in collaboration with the child and the young adults neurology and psychiatry clinic. And the aim of this research is to use machine learning approaches to classify depressive disorder from the kinematic parameters that were extracted from handwriting, and we use the digitalized table in this approach. And finally, I selected only this slide to present our expertise in medical imaging, but this is the field that I really like, and we have very huge experience in medical image acquisition, in co-registration, in visualization. In all of these areas, we have published scientific papers in journals, and I extracted this activity because it's the closest that we did in medical imaging, and that could be useful for the neuroscience population. On the left side, you can see the perfusion map for kidneys, for the kidney that was transplanted and for the kidney from the control group. And the methodology that we used is non-invasive methodology, non-invasive because we don't use contrast in this methodology. This is arterial spin labeling in MRI. And we performed this research on pediatric and young adults to see are allografts that are implanted, are they in function? Are their function is properly? And after this study, we made the graphical user interface GUI for brain perfusion visualization. So our next steps are to apply this interface in some brain imaging studies. And that's all from my side. I just want to conclude that we know how to process signals, to use wearable technology and design it or analyze data from it, to use non-contact sensing, machine learning approaches, medical image analysis. We really like multimodal approaches. That is why the name of the new group is multimodal. And we have a large local ecosystem, and the topics that are in focus for some future work are in the field of neurodevelopmental disorders, affective computing, and motion recognition, and of course using and designing assistive technologies. So we are very open for all your ideas in the future.
Do we have any questions for Lisa? Or perhaps later? Not at the moment. Thank you for the inspiring talk. Our next speaker is Andrei, also from the School of Electrical Engineering. And he will talk about the different kinds of research he's doing.
Thank you, Angela. Okay, so as Angela said, I'm Andrei Savic. I have several affiliations. So the first is I'm a senior science associate at the School of Electrical Engineering in Belgrade, but I'm also a lecturer at a multidisciplinary PhD program under the university, and sort of a freelance researcher collaborating on different with different universities and companies. But today I will talk about, let's say, the main area of my expertise, and this is brain-computer interfaces and closed-loop neurotechnology. And I will give a very short introduction about this. So BCIs are systems that enable users to control devices only with their thoughts, so with certain mental strategies. And it is achieved by measurement of, for example, electrical brain activity, EEG, or some other brain signal measures, and to process it online to extract different features associated with different mental tasks, to classify them and to translate them into commands of external devices, for example, command of a robotic hand, wheelchair, or software application. As you can see here, mostly used signals for this are EEG, so non-invasive, but there are also attempts of invasive BCI using ECOG or implants measuring the local field potentials. This is still let's say an emerging field. It's growing, so there is an increasing number of both scientific publications, but also companies in this domain. Maybe currently the most famous ones are Neuralink and Synchron, but we also have local companies such as Brain Train, who are also gaining bigger visibility, that produce devices that are capable of being employed in BCIs. Just shortly about the applications. Applications of BCIs are still mostly to help people with severe neurological disorders, but also now there are some directions to bring those benefits to the healthy people, so to enhance learning, attention, performance, motor skills, memory, sleep quality, to decrease workload, and so on. I will start with a short history of BCI research at University of Belgrade. I think the slides are a bit messed up, so the animations are not working, probably because it's streamed online, but never mind. Here on the right, you can see my PhD mentor, Professor Mirjana Popovic, with whom we have started this line of research in our lab. Professor Popovic has an extensive expertise in functional electrical stimulation as a method to treat stroke patients, especially they introduced this method of functional electrical therapy, where stroke patients basically train motor skills doing functional movements which are supported with electrical stimulation. So there was this prior knowledge that it's very important to include cognitive component into therapy, so that this stimulation is not only passively moving the hand, but there is actually an input from the brain which is going in parallel with the sensory feedback and the artificially generated movements. And this actually created this idea to introduce EEG and BCI technology in the rehabilitation to quantitatively measure the brain activity during the movement intention when the movement cannot be performed. So basically to close this loop between intention and action, which is artificially produced with electrical stimulation, some robotic device or other, because this is the basis of sensory motor integration and neuroplasticity and motor relearning in stroke. So this was the topic of my PhD thesis. That's me, 10 years younger, you don't recognize me. So, and this is how this line of research started. It's still ongoing, and we are still building up collaborations in this domain. There are some examples: University of Aalborg, University of Glasgow, Aarhus University, and in this line of BCI combined with FES for stroke rehabilitation. The next, what I would like to mention is that 3 years ago, I got a grant from Science Fund of Republic of Serbia to continue this research. This is also in line of BCI for stroke, but here we didn't aim specifically at motor learning. We wanted to see if we can somehow tackle the rehabilitation of sensory functions, and for this we used so-called somatosensory event-related potentials and tried to modulate them with attention strategies. So selective tactile attention tasks in patients with stroke. We have, this is a completely novel approach in BCI, and it's been implemented, tested, and validated in stroke population during the last 3 years. And the third, let's say, line I would like to mention is BCIs for amyotrophic lateral sclerosis, or ALS, which is probably the most devastating neurological disease. It's actually the progressive loss of function of motor neurons. People suffering from this disease so suffer this continuous loss of functions, which in the end leads to so-called complete locked-in syndrome, which is actually the state where the person is cognitively intact but has zero voluntary motor control. So even speech, blinking, or breathing is affected. They are on mechanical ventilation, and helping those people communicate to the external world is extremely important, and only BCI technology can enable this. So ALS patients are still the main clinical target population for BCI. And different type of BCIs have previously been attempted for this purpose. The most famous one is P300 Speller, based on P300 ERPs, and they are used for basically mental typing which can be used for email communication, browser control, or smart environment control. The future of this is envisioned basically as some sort of automatic speech recognition device, where a person, instead of typing letter by letter, can actually imagine speech, which is decoded by the BCI and generated. But until we reach this, I would like to present a remap project of the Danish Innovation Fund, where I was very happy to be a part of. So it's a new BCI system for detection of movement intention and control of so-called soft robotic glove. You can see it there in the picture on the right. So this is the robotic device that is put on the hand like a glove, and it supports the grasping, so the hand closing and opening. And the main concept of this project is to provide this BCI, so this robotic glove controlled device, to the ALS patient in the early stages of the disease, so that they can basically, it can help them support the grasping function, because ALS starts distally from hands and feet, and then progresses towards the other parts of the body, so that basically they can, their grasping function can be supported by BCI. But in parallel, we have collection of large amounts of EEG data. So as the disease progresses, we continuously update these classifiers, and then when they, or if they reach the locked-in stage, we can use the same methods to provide means for communication. So this is it for me. This is a small part of my research directed towards BCI. There are ongoing collaboration with Faculty of Psychology, where we do lots of different ERP studies, but others will probably talk about this more in my name later. Thank you. I think we are a bit late.
Can I ask very quickly something?
Yes.
About this project with ALS patients? Have you already started training the classifier with some patients to see how it works?
Actually, this is, I think, to my knowledge, the largest ALS study in BCI ever. So 30 ALS patients are included in this study. We even brought the system to their homes, so they were tested in realistic environment. This is still a scientific study, but so it's not used by them. We are still tested, but these patients are amazing, and they are actually very enthusiastic and happy to be involved in this, which is actually really fascinating considering the severity of the disease. So there are patients, ALS patients using BCIs. I think mostly I think GTEC system, GTEC has a commercial system, commercial Stellar, which works quite well. But there is a problem of this BCI illiteracy. So some patients cannot use these Stellars, because if they start to be trained when they are in locked-in stage, it's much more difficult. So this is the point, to basically adapt the classifier, because the brain signals change, or they are expected to change during the progression of the disease. So the answer, the short answer is no, but we are really hoping that this will continue, and that we could provide what we have developed so far in the next stages to the patients to be actually used in the locked-in stage. Thanks.
One question.
Okay.
One very brief question. What is your BCI signal of choice in lab? Is it ERP? Is it frequency bands or something else?
It's all of them. Because yes, my PhD is the title is EEG-based control signals in BCI. So we can cover them all, and none of them. So it's always a trade-off. And some of them are better in terms of accuracy, some of them are better in terms of reliability and single trial control. ERP definitely are not fast signals because you cannot detect them mostly on single trial basis. So depends on the application.
Okay, Platon unfortunately won't be joining us today, so Vanya will present our lab next. Vanya, місяць твоя презентація.
In the button.
О, ага.
Ставится, да? Okay, whilst we are waiting for the presentation to upload, just to briefly introduce myself. My name is Vanya Kovic, as everyone here knows already. I'm a full professor at the Department of Psychology, University of Belgrade, which is really nearby from here. And for the one of the workshops, some of you will have opportunity to work with Voicelab in that lab and basically to see the lab. For the others who are interested, we are very happy to show you how the lab looks, given that it's really nearby. Now, this lab, Laboratory for Neurocognition and Applied Cognition, is fairly new lab. We are not even a decade old yet. And we basically started by building Faraday cage 8-9 years ago now, with the support from the people from the University of Novi Sad, Faculty of Technology. And also, we started very similar, like we heard before from the colleagues from New Bulgarian University, Ivo Populanov and his group, by basically creating and making handmade system, which is one channel system, but which was really useful for doing P300 studies. And we started some research with placebo, nocebo effect, with some grammatical priming, basic studies, and so on. So this was really the beginning of our journey. Very soon afterwards, we were lucky enough, thanks to Professor Ljiljana Popović, to be introduced to the people from the engineering department of Belgrade. At that time, particularly to Andrej Savić, with whom we actually started collaboration back then, and we are still really happy to collaborate on any project that there is. Initial studies that we did with support of this group were to do with sound symbolism and neurocorrelates of sound symbolism in a natural language, that is Serbian language. And then also we did some semantic research, especially with regard to taxonomic and thematic processing. Both of these research were actually published, and were first published papers coming from this group. In subsequent years, we were lucky enough that some people that we collaborated previously with, and here I have in mind Professor Kim Plunkett from University of Oxford, my ex-mentor, then Professor Kenneth Holmqvist from University of Lund, Swedish University, and then Professor Guillaume Thierry, who's based in Bangor, to be actually given very valuable equipment. We are talking about NeuroScan, SMI, eye tracker systems, and so on, based on which we actually started doing research within much bigger group, whereby we expanded the research interest, which was still to do with semantic memory, categorization, and more basic psychological research, also language-related research. More recently, Iris already spoke briefly about this. We actually started doing some really interesting work. This is basically the beginning of setup of what Iris was mentioning before, and about which you will hear in the workshop on Thursday. So for some of the projects, for us, it was really necessary to start, or very valuable, to start combining different measurements. So as Iris said, EEG, eye tracking, cytogalvanic response, and heart rate. So this is the beginning of setup of this system, and then meanwhile we completed part of that project, and there are quite a few studies which came out of that. It's really easy to work with these people, and they consider it very easy job to be done. We as psychologists consider it really demanding, and we are so grateful to have opportunity to coordinate and collaborate with them. And as I said, you have opportunity to hear how exactly they combine the system and how can we do this kind of research on Thursday. Meanwhile, in these last 7-8 years, there are quite a few people who actually were part of this team, and I'm really proud to say that each one of these people had the opportunity to work in this lab, either to finish their doctorate, master's studies, or do part of their work in our lab. At least half of them, pretty much half of them, are at different universities, and also waiting to some of them, for which I know that they are watching us from some other places where this conference is now being organized, where they continue doing similar work, or actually they move to some other fields and disciplines regarding psychology. But with these people, we actually managed to publish quite a few presentations meanwhile, but also we use any opportunity that we have, and these people are coming to visit us, not only to get together and exchange what they are doing where they are now, but also every time they come, we actually get opportunity to ask them to basically share their current experiences and knowledge, and also we are joining collaboratively in some future work and present work with some of these people. Speaking of publications, I told you that we started mainly looking at some language studies, semantic studies, more sort of to say basically psychological studies, categorization being one of the core of the interest of this lab throughout the years. But more recently, we actually moved our field of interest in more applied domain. You heard about projects such as dyslexia from Katarina. You will hear that we are moving towards understanding how the early reading works, and EEG methodology is going to be one of the methodologies that we use in order to understand that particular system. From Voislav, you will hear what he, together with his colleague and Andrei's supervisee, are doing with the migraine patients later during the day. Also, we are researching in a field of deception detection, and we are doing this work collaboratively with Professor Giorgio Ganis, now based in Britain, and my student, doctoral student Nikola Milosavljevic. And I'm especially happy to say that we are part and basically the leaders of the project, which is titled Artemis. You will hear much more about that project from Angela tomorrow, because this is one of the plenary lectures. And I can say that within this project, just that much, that we are actually trying to set up some standards in how ERP studies could and should be done, how they should be reported, and so on and so forth. But Angela, as I said, will tell you much more about that. So this is much more on methodological front of things and interests. And we are very welcome to receive more people because this is a huge project. I can just tell you that we are currently collaborating with people such as Susie Stans from University of Singapore, already mentioned Professor George Ganis, Robert Ostenveld, Remy Bouy, Guillaume, also probably some people who are present here, not probably, but definitely setting this conference in these other fields. So you will hear more about that project and you will have opportunity, if you like, to join us in any of the research that you're doing. Also, we are very interested in looking at the possibilities to gain some grants, which will actually make our lives in terms of research much easier. So far, we were actually getting support in the way that I described, but this is what we are really looking forward to doing in terms of improving our research within our lab. Shortly, this is what our lab is about so far. I have a sense that we are basically only starting, although we have 8-9 years behind us. So really happy to join forces with people who are doing it. Thank you. So now we will actually have a small discussion or opportunity to discuss further and get to know each other further. We have a little break as well, and then after that we are going to the next sessions. Yeah.